right, you guys. We're going to start Unit 3 today. Um, I hope y'all had a good weekend. We are in Nationals right now on our way to Florida, and I'm super excited. Um, but while I'm gone, you still have to learn math, sorry. So we're going to talk about parallel lines and the relationships of the angles formed by these lines and what that helps us do in solving all kinds of different shapes that we're going to get to as we progress through geometry. The first thing I want you to consider are the angles that we already know. Like, for example, if we had two lines intersecting like this, we have a pair of vertical angles at that intersection that we know are going to be congruent because they're opposite. We have pairs of supplementary angles like those two that form a linear pair that are going to add to equal 180. And we could even have complementary angles depending on what kind of lines we have. If they're perpendicular, they intersect at right angles. With that being said, what this unit is about is not so much just looking at a single line or where those individual lines intersect, but maybe if we were to picture further down that line another one intersecting. So let's say we have line L, line A, and line B. We now have a separate grouping of angles. There are still vertical angles in this relationship. There are still linear pairs. But what this unit is all about is going to be taking one angle from this first intersection, or as I'll call it, a pod. We'll take one angle from this pod and relate it to another angle in the second pod. Okay, so we're going to be able to relate different intersections together by these four names. Well, if you look at your notes on page 37, we have what's called a transversal. Wow, I can't even spell that right. A transversal is just a line that intersects two or more coplanar lines at two or more distinct points. So in our picture that we just talked about, L would be considered the transversal here because it's crossing over line A and line B. That's two separate lines, so L is the transversal. Keep in mind you can have multiple transversals depending on your picture, and you need to be able to pick out which transversal relates to which. But we'll start a little simple here. When you talk about your transversal, and we'll call this T for transversal, A and B, our T here is the transversal because it's cutting across A and B. And these numbers here, 1, 2, 3, and 4, are representing the four angles where T intersects A. And then 5, 6, 7, and 8 are representing the four angles that are formed by T intersecting line B. Okay? When you talk about interior and exterior in terms of a house, interior would be like inside the house. Exterior would be outside of the house. Well, in terms of lines, the interior is all of this space that stretches between lines A and B, and it could be on either side of the transversal, just all the space between. Exterior would be everything above line A and below line B. No matter which side you're on, will be considered the exterior. So 1 and 2 are exterior angles, 7 and 8 are exterior angles, 3, 4, 5, and 6 are all interior. Okay, you need to understand that because it's going to help you figure out these angle relationships. There are 4 different types of angle relationships in addition to the ones we know, like vertical angles, linear pairs, and so forth. Our first one, let's start with alternate interior angles. When you see the word alternate or alternate, that means you're going from one side to the other, okay? So we want a pair of angles where they're on opposite sides, of the transversal, but interior means we still want them to be between the lines. So I want you next to this somewhere write opposite sides slash between the lines. So I'm thinking, okay, between the lines, let's say we look at angle 3. Angle 3 is on the left side of T, so I want to pick something that's on the opposite side of T, but still between the lines. So I'm thinking either 4 or 6. Do you see how 3 and 4 are in the same pod together? They're in the same group of angles. I cannot pick that one for it to be alternate interior angles. It needs to be in a different grouping of angles. So that would leave me 3 and 6 are diagonal from each other. Another pair of alternate interior would be 4, because it's on the right side between the lines, and 5, which is on the left side between the lines. So that would be another example of alternate interior. Alternate exterior, same kind of concept. You want them opposite sides, but this time we want outside of the lines. So on this side, I want you to write opposite sides, outside lines. So we're thinking, okay, exterior would be angles 1, 2, 7, and 8. Let's say we pick angle 2. And I'm going to use a different shape just so you can see later. Let's see, we'll put a circle next to alternate interior. We'll put a square next to alternate exterior angles. So do you see how 2 is on the right side of the transversal but outside? Okay, now I want to pick something outside in the other grouping, but on the left side would be 7. So 2 and 7 are an example of alternate exterior. 1 and 8 are an example of alternate exterior. Consecutive interior angles are also known as same side interior. You will most likely see consecutive interior, though, on quizzes and tests. Consecutive, if you were talking about numbers, would be numbers that come one after the other, like 1, 2, 3, 4. So consecutive interior angles need to be inside the lines for interior, but consecutive means one after the other. That means they want to be on the same side. So let's do a star by 3, which will represent our consecutive interior angles. 3 is between the lines and on the left side, so I want to pick the other between the lines on the left side angle. So 3 and 5 would be consecutive interior, as well as 4 and 6. And if you go back up to corresponding, let's do a triangle for corresponding angles. Corresponding angles are angles that are in the corresponding positions. Like if I said, okay, Jack and Jill both got a 90 and a 100 on their tests, or their corresponding grades were a 90 and a 100. You would put them in the same order as I named them. So Jack got a 90 and Jill got a 100. Corresponding angles, again, same thing. They would be in the same spot as the other. So you want to think same spot for corresponding angles. Let's say, for example, we use angle 1. Angle 1, in this particular pod at the top, I would describe it as upper left angle in that pod. So I want to look for that same spot, upper left, in the next pod. Upper left would be angle 5. So 1 and 5 are a great example of corresponding angles. 2 would be top right, so it would match top right of the other pod. 2 and 6 are another pair. 4 and 8 are another pair. 3 and 7 are also another pair. All right. In your notes, we have that 2 coplanar lines that never intersect. If you have 2 lines that never intersect, they're just called parallel. So parallel lines are 2 lines, 2 coplanar lines that never intersect. So if I'm picturing the plane, here's one line, and it's never going to meet this other line. All right, so we want to look at the other types of relationships we could have. There are parallel lines. There are skew lines. Skew lines are two non-coplanar lines that never intersect. Do you see how the definitions are very, very similar? The only difference in words is coplanar and non-coplanar. Um, Let me get, okay, here is our lovely paperclip holder. Okay, a set of parallel lines are in the same surface. So if I'm looking at the top surface of this paperclip holder, here's one line. It's on that same surface. Here's another line. I see that they do not intersect, but they're still considered on the top part of this top surface of this paperclip holder. Okay, a skew line needs to be something that is not going to intersect my pen line, but still on a different plane. So if I have my first line on the upper plane, let's look at the side plane. If I pick this top line on the side plane, I intersect right at my fingertip. If I pick this side, I intersect again at the tip of the pen. If I pick the bottom, and I'll turn it so you can see it, do you think these are going to intersect? This one's going on forever in this direction, and my finger is going on forever front to back. A good way to identify skew lines is that they are opposite directions. Like, for example, this is left to right, and this one is front to back. Those are different directions and different planes. Okay? I could have also said that this line is skew because it is on the back part surface, and this is on the top surface, so those are different surfaces, and they're also going different directions. Parallel lines would be the same surface, same direction. So parallel is same surface, same direction. Skew is different surface, different direction. And you can write that next to your definitions. Parallel would be same surface, same direction, and skew would be different surface and different direction. So let's look at our picture here. We want to pick out a line that's parallel to line MN. Well, MN, do you see how it's on this slanted part of our prism? We want to pick a line that is parallel to this one, but also containing point J. Well, point J is here. Here's my line MN. Here's point J. And I want to pick a line that is parallel to that. Well, we're still needing to be on this slanted surface, and I need to be going the exact same direction. So that would be line JL. The next one, skew to MN. Skew to MN means I cannot be on this blue surface part. I need to be on a different surface going a different direction. So if I'm thinking of, okay, not the slanted part, let's picture the back wall of this prism, which would be plane JNO. If we want to be skewed to MN, it means it cannot touch point N on that surface. It's got to touch a different point. So we could say, I think that's an O, OK, because it's going, instead of diagonally, it's going front to back. Or it could even pick JK, because JK is going up, down. MN is going diagonally, and they're on different surfaces. So you could say JK or OK. If we wanted something perpendicular to MN and containing J, perpendicular to MN means it needs a right angle in it. I don't see any right angles, so what you're going to have to assume, which if there's ever a question, don't assume, But we can see that this is forming a rectangular plane, so I know that this is perpendicular. JN would be a good example of something that goes through J but is perpendicular to MN. Name the plane that contains J and appears to be parallel to plane MNO. MNO is this back surface right here. If I want to be parallel to that, I need to be the exact same orientation, but brought off of that surface. So we're looking at this plane right here, which I would name with 3 letters, just like I originally had. So I could say it's plane JKL, or you could switch the order and do LKJ, KLJ, and so forth. These relationships of angles that we just discussed, those occur no matter what kind of transversal and lines that you have. You can say more things about those angle pair relationships once we have parallel lines that are being cut by a transversal. So we'll be able to say more things that will allow us to solve for missing pieces. If you do not remember, the symbol for parallel, if I was talking about lines, would be like line L is parallel to line T. That means parallel. And on a picture, let's say I was drawing my lines and showing that they're parallel, you would see what's called like a bolded arrow. So those 2 lines I could say are parallel to each other. Or if we had another set of parallel lines going somewhere else, we'd have to differentiate, just like we would with congruent tick marks, and put double arrows. So these 2 are parallel to each other, and those 2 are parallel to each other. You're going to be able to need to identify those, whether it's by the picture or anything else. All right, I'm trying to see how much more we have. Okay, these 4 postulates you have got to know, and you have to know the most important part about them. They get a little wordy, but that's okay. I'll write off to the side the things that you need to actually know. In a proof, the conditional statement must be used setting forth the congruent angles to justify conclusion. I feel like that's confusing until you see a proof, but star that top little paragraph. We will do proofs with parallel lines, but not until Monday. So I just want you to understand that you'll have to write them in conditional statements, but we will get there, and I'll be more specific about that later. All right, so we want to look at these following postulates. If you see a pair of corresponding angles, which remember means same position, upper right, if you see them when we have those parallel line marks, then we can say they are congruent. Alternate interior angles. Remember, those are opposite sides of our transversal, but still between the parallel lines. And if we have parallel lines, I can say those are also congruent. Alternate exterior angles. Alternate exterior angles are also going to be congruent if you have those parallel line markings. And in this case, we have angle 1 and angle 8 because they're opposite outside. Consecutive oddball. So if you're your only options are that they add to equal, aka supplementary, or they're congruent to each other. Okay? If you can remember that consecutive interior, meaning the same side interior, when you have parallel lines, is 180, then you can automatically say, oh, okay, then the rest must be congruent. This is the one that will help you memorize the rest, I promise. So let's look at an example. Here's the more markings. These are some of the different markings you could see for parallel lines. This one we talked about, where you see the bolded arrows. This one we still talked about, you see the bolded arrow. You could also see the bolded arrow on the end of the line as opposed to a regular end of a line that just looks like a single, non-unbolded arrow, if you will. All right, so let's describe the location of some of these questions. Let's look at this first one. We'll call this number 1. Number 1, zoom in a little bit. All right, we have 108 degrees here and 3x degrees there. When you're identifying these problems, first you want to identify the transversal. Our transversal is the line that's crossing over my other two. I'm going to do a quick check because I can't write equations until I see those parallel markings. And then I'm going to keep moving on. All right. In relation to my transversal, I'm going to ask myself, okay, are they on the same side of T, like both left or both right? Which my answer is no. So I'm thinking alternate something. If they are outside of the lines, they are alternate exterior, and I'm going to abbreviate like that. And if they are alternate exterior with parallel lines, I can say they are congruent based off of the theorems we just talked about. Remember, the only one that's going to be supplementary are consecutive interior. So I can say 108 is going to be equal to 3x and divide by 3 to solve. All right, so 108 divided by 3 leaves me with an x equals 36. If I was done and all they asked for was x, I'm done. End of story. If they wanted me to plug back in to find the angle, make sure you're reading the question. All right, let's look at this second one, which I'm going to label as number 2. We have a 60-degree angle. We have angle 1 and angle 2 on the bottom. If I'm just looking at the bottom line relationship, do you see how angle 1 and angle 2 are in the same pod? They are either going to be a linear pair or vertical angles. Since they're next to each other and they form one solid line, they're going to add up to 180. Those are a linear pair. However, I can't start with those two together because I don't have any information in them. So let's just say we compare angle 2 and 60 degrees. In this problem, this line is my transversal. I'm just going to stick with T. Do you see how 60 degrees and angle 2 are both on the right side of the transversal, and they're both between the lines? The same side between the lines, that means that 60 degrees and angle 2 are consecutive interior. And if you remember, those are the only ones that add to equal 180. So I know that 60 plus whatever the measure of angle 2 is going to equal 180. That makes angle 2 120 degrees. So I'm going to cross that out and put 120 in there. Now I can figure out how angle 1 and angle 120 relate because we just said they were supplementary. So if I subtract 120 from 180, I'm going to get angle 1 is 60 degrees. You could have gone another way though. You could have said, oh, but I want to relate 60 degrees and angle 1 together first because those are opposite sides between the lines. 60 degrees and angle 1 are considered alternate interior, which are going to be congruent. So you could have automatically said that with 60 from the get-go and solved for 2. I, again, do not care. There are several ways to work all of these problems. I just want to make sure that you're doing the correct relationship. You need to be able to quote to me alternate interior, consecutive interior, or any of those angle measures. All right, so let's look at number 3, just below number 1. Angle 111 degrees and x plus 21. In this problem, my transversal is running across. I still have parallel lines. And I'm looking at these are same side of the transversal, but they're not both between the lines. One of them's inside the lines, one of them's outside, which tells me it's not consecutive interior. And it's not alternate interior or exterior because they're not on opposite sides. So I have to check corresponding. 111, I would say this is the top right angle in that pod, and x plus 21 is also the top right angle. So those two are going to be corresponding, and I know corresponding is congruent angles because of the theorems. So I would set 111 equal to x plus 21. Subtract 21 from both sides, and x is going to be 90. final answer. All right, let's look at the one below this. We'll call this number 4. Number 4 does not necessarily directly relate. Do you see how it looks a little bit like number 3? But instead of having one, they're both same side of the transversal, but instead of having one inside the line and one outside the line, these are both outside, and there's no consecutive exterior relationship. That's not how that works. However, this position and this position, those are corresponding. They're both upper left, and since those spots are corresponding, I can say that they're congruent. So even though I don't have a measure there, I can still call this 4x minus 8 because that would make it the same as that angle. Now I can see that these two angles are in the same pod right next to each other, so they're going to form a linear pair, which would say that 64 plus 4x minus 8 equals 180. So if I'm simplifying, we would have 4x plus 56 equals 180, and we can subtract and get that 4x equals 124, and when you divide by 4, x would equal 31. Since x doesn't necessarily represent an angle measure, you're not always going to have degrees on the end. Wait until you plug back in to figure out if it's going to be degrees or not. All right. Let's do one more example. Generally speaking, when I give you a problem and I want you to identify what kind of angles we're looking at, you should be able to tell me that, oh, those are corresponding, those are consecutive interior, those are alternate interior, alternate exterior. You need to be able to tell me immediately. We'll do a lot of practice with this, but this is definitely going to be, you're going to have to be able to identify and solve on your quiz that will be Tuesday. So make sure you understand this. And I know Miss McKeever, who is in room 2590, which for first period, that's just the same classroom. But she is more than happy to tutor y'all while I'm gone. So if you have any questions, please stop by and ask her. I will be back Tuesday morning if you want to ask me questions before our quiz. But hopefully y'all will feel like you understand this and don't have too many questions. Yeah, so please make sure you're working on your algebra review for this unit that you got yesterday. I will make sure that yeah. If you have questions, please come in for help. Ms. McKeever would help you, Mr. Ryan, Mr. Henderson, Coach Murdoch, Mr. Dunlap. Those are all good teachers that will help you if you are struggling. All right, I will see y'all Tuesday. Have a great weekend. Oh, P.S. You should know this. Your homework is from your green sheet, and the homework for today will be to complete homework number 14, which corresponds to your green sheet. All right, y'all have a great weekend. Bye.